At its narrowest navigable point, the Strait of Malacca is 2.5 kilometers wide. Through that gap, every single day passes nearly 1/4 of all the physical goods traded anywhere on Earth. Not because it was chosen, because there is no alternative. And that absence of alternatives is what makes it, quietly, one of the most consequential geographic features in the modern economy. From above, the strait looks unremarkable. Coastal haze, fishing boats, green shoreline on both sides. And somewhere within that ordinary scene, the slow procession of enormous vessels moving in both directions through the channel. Container ships, bulk carriers, oil tankers, each one following a path connecting the Pacific Ocean to the Indian Ocean through the only efficient passage available. Ships traveling from the South China Sea toward India, the Middle East, or Europe have no meaningful detour. Rerouting through the Sunda or Lombok Straits adds roughly 1,500 nautical miles, 3 to 5 additional days at sea, higher fuel costs, and the loss of access to Singapore's critical refueling infrastructure. For most vessels, that detour is not a contingency plan, it is an economic penalty severe enough that it only becomes rational when the strait itself becomes worse. So the ships keep coming. And the question worth asking is, what exactly are they carrying? The easy answer is goods: electronics, fuel, machinery, raw materials. But that answer describes the cargo without describing what the cargo actually represents. Because the vessels passing through Malacca are not simply moving products from one country to another, they are moving the individual components of a production system that spans the entire Pacific Rim. Chips from Taiwan destined for assembly lines in Vietnam, steel from Japan bound for factories in China, crude oil from the Middle East heading toward refineries in South Korea, that will power the factories that manufacture the goods that will eventually move back through this same corridor on their way to consumers in Europe and North America. The strait is not just a trade route, it is the central artery of a manufacturing machine that has been assembled piece by piece across a dozen countries and 3 decades of industrial integration. And that machine has a specific operating requirement that changes everything about how the strait should be understood. Modern Asian manufacturing does not run on inventory, it runs on timing. Over the past 2 decades, the factories, assembly plants, and logistics networks across this region were systematically redesigned to eliminate storage buffers and reduce idle inventory to near zero. Components are manufactured in one country, shipped to another, and arrive at the production floor within hours of when they are needed. Not days early, not hours late, but precisely on schedule. This is not simply a cost-saving measure, it is the fundamental operating logic of the entire system. The efficiency gains are real and significant, but they come with a structural consequence that is rarely stated directly. The system no longer stores resilience inside its factories, it stores resilience inside its shipping schedules. The buffer is not a warehouse. The buffer is the ocean and the vessels moving across it. Which means the Strait of Malacca is not simply carrying goods. It is carrying the timing system that keeps Asia's manufacturing economy operational. So far, we have seen what the strait carries and why the ships have no real alternative. The next question is what actually happens inside a factory when one of those vessels is delayed, and why the answer is more severe than most people expect. A vessel delayed in this corridor does not create a delayed delivery, it creates a missing input, a component that was scheduled to arrive at a specific production window that will now close before the ship docks. In a system with no internal buffer, that missing input does not wait quietly in a warehouse for the next production cycle. It stops the line, and when one line stops, the operations downstream that were scheduled to receive its output stop next. The delay does not stay local, it propagates forward through every dependent process that was built around the assumption that the previous step would complete on time. One disruption in the strait can reach a factory floor on the other side of the continent within days. Not through any dramatic chain of visible events, but through the quiet failure of a timing assumption that nobody thought to question until it was violated. This is the dependency that makes Malacca structurally different from other choke points. The Strait of Hormuz constrains the flow of energy. The Suez Canal shortens the distance between markets. But the Strait of Malacca sits inside a manufacturing system that has been deliberately engineered to carry no redundancy. A system that is, by design, only as reliable as its least reliable corridor. And its least reliable corridor happens to be 2.5 kilometers wide. Governments understand this. By the early 2000s, the vulnerability had become significant enough to earn a name, the Malacca Dilemma. China, already emerging as the world's manufacturing center, found itself increasingly dependent on a single overseas corridor that it neither controlled nor could easily replace. The challenge was not simply economic or political, it was geographic. Over the following decades, alternative routes were explored. Pipelines were built across Myanmar. Rail corridors were proposed through Central Asia. New infrastructure projects promised to reduce dependence on maritime chokepoints. But the scale of China's industrial economy had already outgrown most practical alternatives. The volumes moving through the Strait of Malacca every day are so enormous that no combination of pipelines, railways, or overland routes can fully substitute for what the corridor provides. Geography imposes constraints that technology cannot easily remove. The coastline remains where it is, the oceans remain where they are. And for the manufacturing system that connects East Asia to the rest of the world, the most efficient route between two oceans still passes through the same narrow corridor it always has. And here is what makes that dependency more serious with each passing year, not less. Every efficiency gain, every reduction in inventory, every further compression of just-in-time logistics, tightens the system's tolerance for delay and reduces the margin that once existed between a disruption and a crisis. The system is not becoming more resilient as it grows, it is becoming more precise. And precision in a physical system is another word for fragility. Seen from a satellite, the Strait of Malacca looks like empty water between two green shorelines, but what is actually moving through it hour after hour is not goods. It is not cargo, it is not trade statistics. It is the timing system that modern manufacturing depends on. The invisible sequence of arrivals and departures that keeps production lines running across a dozen countries simultaneously without any single actor seeing the whole. The strait does not move goods. It moves the schedule that holds the entire system together, and the schedule has nowhere else to go.